And we are live. Hello, welcome to this AeroGear community hangout. The last one we had was on Google Summer of Code. And we are live. And hello, welcome to this AeroGear community hangout. The last one we had was on Google Summer of Code. So I hear myself. That was a mistake. I'm sorry.
Lots of echo.
Sorry. Okay. Yeah, we have the hello to this crazy start of the AeroGear community hangout. Last one was on Google Summer of Code, where we demonstrated the Kafka proof of concept. Today we decided to do another one because the AeroGear community right now is looking into Golang a little bit for some projects that we do on top of OpenShift. So yeah, with me today is Dara, and Dara will be the presenter for some of Golang stuff, like how to run services, get them tested, and get them released. Yeah, Dara, take it over.
All right, good morning, good afternoon, good evening, wherever you are. My name is Dara, and I work in the AeroGear team. Today I'm just going to talk a little bit about Golang. So I've started learning Golang about 2 or 3 months ago. So I'm not an expert by any means, but we recently started building the first, our first ever service that was written in Golang as part of the AeroGear project. That service is to do with app metrics. I won't go into detail about that service in particular, but I guess what I want to talk about today is just some of the stuff that we kind of learned going through that process. And one of the things I'm going to focus on heavily is releasing containerized applications, and hopefully we'll get a nice little demo if all things go well. So let me see. Can I ask you, Matthias, can you see my screen properly? Yeah.
Perfect.
Okay, cool. So that's my nice title slide. So just as I said, my name is Dara Hayes. I work at Red Hat. Those are my social things. A little bit of background about me. Started learning Go about 3 months ago. Before that, I was a Node.js developer for a number of years. So it's been quite an experience for me, quite a big shift. But anyways, just straight into it. First thing I'm going to start off with is this quote that I found online. I think Node is not the best system to build a massive web server. I would use Go for that. And honestly, that's the reason why I left Node. There's the realization that, oh, actually, this is not the best server-side system ever. And the person that said that was Ryan Dahl, the creator of Node.js. And I'm not putting this slide in here to laugh about Node, because I absolutely love Node. It's just, it was an interesting thing to find. And I also think that's a great example of someone just leaving their ego at the door. Arguably, this guy's life's work was Node. He created this thing that's so big now, and he still had, the maturity to admit to say what he said. So I just think it's an interesting point. And coming as someone that's really heavily invested in the Node community, that was an interesting thing for me to find. But anyways, what I have here is this little repo. It's the Go Hello server, and it's basically a very small Golang project of a HTTP server that just shows off some small little best practices that will, when I say best practices, it's a mixture of Go idioms and sort of things that we consider to be best practices that I've kind of, distilled out of this metric service that we were building in the AeroGear community. So we're going to take a look at some of that stuff in a few minutes. So the first thing I'm going to talk about in Go is just HTTP frameworks. So this is a question that I would have definitely asked as soon as I got into Go. What frameworks are out there for doing HTTP related kind of stuff? Especially coming from the Node community, there's so many different options. But it turns out that the built-in library in Golang is actually really good. The only one gotcha is that routing is quite hard, but there's a library called Gorilla Mux, and Gorilla Mux makes things very, very easy. So a mixture of the built-in HTTP library and Gorilla Mux makes a perfect recipe for a nice application in Golang for a server application. So the next thing I'm going to talk about real quick is dependency management. And in Golang, this is known as vendoring. So for a long time, there wasn't actually a dependency management tool for Golang. You just use go get and it would pull something from GitHub, but there are a lot of issues with that around like versions and all sorts of stuff. There have been lots of open source projects that try to solve this, but there's now a tool called dep and it's being maintained by the official Golang team. It's not an official tool, but it's the official experiment. So my recommendation for anyone interested in learning Go would just be to use dep, because more than likely it's going to become the official tool eventually. Anyone that's kind of, familiar with the Node.js world would kind of recognize this kind of pattern. You've basically got two files, a lock file, and then your file that actually defines your dependencies. And these are just some example commands of how you would initialize dep in your Golang project. And that's an example command of how you would add someone else's library as a dependency. So it's quite simple. Before I keep going, I'm just going to interject and say I'm going to get into some code examples soon. I just want to kind of power through some of this theory stuff real quick, and then we'll get into some more interesting stuff. So project structure. This is sort of the project structure that we've found to be really useful. Essentially, you've got your two files that I mentioned earlier on for dependency management. And then you've got these three folders. Vendor is where your dependencies will be stored. That gets auto-generated. My advice is to git ignore that. Don't check your dependencies into the repo. Some people do that in the Golang community, but I've found it to be easier if you just don't. So that's, like I said, some of these best practices are probably slightly opinionated, but these are what we're doing, and these are what are working for us the best. So then these two other folders, we've got package and we've got CMD. Package would contain individual folders like with our business logic. So these are kind of like, this could be business logic related to the app. This could be configuration parsing. This is data layer kind of stuff. And this might be the HTTP related stuff, all in their own little libraries. And then in here, CMD would be the entry point to your app, right? So if you have multiple entry points, if there's like multiple apps in your one repo, you'd have each entry point in under this folder. It just provides a nice way to find where is the beginning of an app. So like index.js in Node or something similar. So let me continue. Another little thing that I've found is really, really nice when building Go applications is this concept of dependency injection and interfaces. So basically, there's a really nice way to structure your app where you start off with your database logic, for example, right? And you can initialize this database logic first. And then what you do is you initialize your business logic or your app logic by inserting the database logic instance, like the instantiated class of your database driver, for example, goes in here. And then this guy is instantiated and gets passed into the HTTP level stuff. And I don't know if I'm making myself clear, but basically what this means is that this guy doesn't directly import any of the database logic, right? It's inserted in as opposed to directly importing. And what that means is that there's very loose coupling between the components in your app. And it means that you can test parts in isolation very easily. You can mock out parts as needed. And that makes for a really nice, just makes for a really nice project to work with. So the next thing to just talk about a little bit is app configuration. So my rule of thumb with any project is that the app should be able to start without any config in like your local development environment. So, it should be ridiculously simple to start your app. just one command kind of thing. And personally, I like to use environment variables to configure applications because it's kind of in line with something called the 12-factor app. So if you've never heard of the 12-factor app, definitely check it out. You can follow this link in the slide deck. Just Google 12-factor app. It's kind of like a Bible for building like modern applications that are robust. So it's a really nice thing to familiarize yourself with. So the next thing is testing. So a nice thing about Go is that the testing framework is built in. You don't need to like import any external dependencies. Like coming from the Node background that I have, like you might be using Mocha or Jest or so many other frameworks that are out there. This is just not a question that you need to ask yourself in the Golang world because it's built in. It's also got really, really nice HTTP testing capabilities. Just some best practices. Test files are normally kept in the same directory as your actual source files. So if you have myapp.go in the same directory, you'll have a myapptest.go. And that's a standard approach. The only time you kind of go outside of that approach is maybe if you have integration tests where they require like live databases or something. So you might separate them in a different folder so that they don't get run as part of the normal test suite. And like I said before, dependency injection allows us to easily test our components in isolation. You know what? I think what I'm going to do before continuing with the slides, I'm just going to actually go into the Go Hello Server example that I talked about at the beginning. So there's this repo here, and this shows off a lot of the concepts that I'm talking about right now. So what I'm just going to do is jump over to that real quick, and just maybe by seeing some code and stuff, this makes more sense. So this is my project directory. This is kind of the similar shape that I showed you earlier on. There's some extra stuff in here, but we'll get to that. But it's still the same basic structure. We've got our CMD, we've got our package, and we've got our vendor, and we've got some other stuff that gets created, and I will show you that soon. So to start off, we got our hello server.go. And there's quite a lot of code in here, but essentially we have a config package that loads in config, and under the hood, that's reading stuff from environment variables, and it passes in reasonable defaults if there aren't any present. The reason for that is so your app will start, without any config in a local development environment. Going back, so we load in our config, we create a new router that's using mux underneath. So the Gorilla mux that I talked about earlier, the router stuff. I know I can't explain all of the code in detail, but just to give you the general idea. So what we do is we create our config, we create a router, we initialize the business logic. This is essentially, I won't get into it, but essentially it's setting up like the hello world routes. So what I'm going to do is just run the app first. So this is how you run an app. Go run cmd hello.go. Oh, it's running already. So it's running already in here. Let me just kill it and start it again. Actually, Matthias, just real quick, is the text on my screen big enough?
Yeah, perfect.
Okay, cool. Go run. Hello server.go. So application has started. I'm going to go over to a bigger terminal just so we can see. So we're going to curl HTTP. So hello world, and we've got this version number. That's essentially what our service does. There's some really nice stuff in here if you want to learn about how dependency injection and interfaces works. Basically, the general gist of it is that we've got our business logic contained inside this hello folder, and then we've got the actual HTTP server logic in this web folder. The HTTP server makes calls to the hello, like to the business logic, but it doesn't directly depend on that business logic. Instead, we define an interface. So we define what kind of functions we want, and then it gets passed in as part of the app instantiation. So what that means is we could, you know, take this implementation here in the hello, you know, in the business logic, and we could mock it out if we want to test different scenarios and all that kind of thing. There's no database in this app, but you could do the exact same thing with the database logic. So definitely check out the interfaces and dependency injection kind of patterns in Go if you're interested in it. But I'm gonna go back to the slides and just continue. So a really nice thing to have is code coverage. Go has code coverage reporting built in as well. It's got a lot of things built in, to be quite honest. Something that we found to be really useful is to upload your coverage reports to a service called Coveralls. Coveralls is free for all open source projects. So what we can do is you can basically sign up using your GitHub account. You can add your project, and then we use a CLI tool called Coveralls, which will upload the coverage that's outputted by the testing, and it gets put on that service. And then we can do things like have coverage reporting for every pull request. We can have coverage report like fancy badges on the readmes and all that kind of stuff as well. One little gotcha is that it's kind of hard to aggregate coverage across your multiple packages inside a Go repo, but I will show you an example of that in a while. So the next thing is around building and testing. So Go is a compiled language, so there is a build step needed. Depending on how complicated your app is, you might have multiple different test commands, like whether you want to do unit tests only, integration tests, both, all that kind of stuff. And you might have commands to build like container images as well, which is going to feature prominently in later on in the talk. So I'm going to continue on with it. But basically, sorry, let me just go back to that for a sec. Basically, something that we found to be really useful for all of this is Make. It's used in a lot of Go projects. Originally, as a Node programmer, I kind of was scared of Make because I was used to using more modern tools. But it turns out that Make is just, it's fantastic, and it's really, really good. And it's really simple as well. And simplicity is something that I think we should always look for. All right, so this is probably like one of the biggest sections is in my talk. One of the things I really want to stress is like how we deal with Docker, right? So the title of this talk was all about containerized apps. So this is like the real meat of the talk, right? So the approach that we've taken is to compile the binary outside of the image and then pass the binary in as part of the build. So basically we do something like go build my app and then do Docker build and pass in the path to the executable. And an astute listener or a viewer might see that implementation and start like raising their eyebrows, right? They might be asking themselves, like, no, we should do all the building inside the container because the container is guaranteed to be a clean, fresh environment. You know, you're not going to accidentally have the wrong dependency versions, you know, all that kind of stuff that would, you know, that might happen if you built a Docker image on like a local machine, right? So my response to that would be that the CI environment is guaranteed to be clean. So basically, you don't need to worry too much about that as long as any images that you're actually going to release or push into production are always built in an actual CI service, which they would be anyway. So I think this really, really simple Docker file is worth that one small caveat, right, in my opinion. And the reason for that is because it's just so simple. It's low maintenance. You don't need to build any tooling around it, right? Like when you start doing things like having multiple Docker files or like builder images and all that kind of stuff, you end up having to write lots of custom tools to support that. And usually those tools are probably going to be pretty crusty and not the best. And so, you know, I just try to avoid it when you can, like keep things as simple as possible until you really need to, you know, take it further. The next thing is that this Docker file is really developer friendly. Like it's really easy to use locally, and it'll also work in production. And it just gives developers the simplest possible workflow. They don't need to worry about multiple Docker files. There isn't some like crazy hard to remember process to follow. It's just one command and it's super simple. So yeah, and then the last thing of just the one last point on that is if we have released versions of our project, like in binary format, anyone can download any binary from any given point in time and they can make an image with it. So it kind of allows you to have really reproducible builds in that sense. So that's why I really like it. So this is going to be quite a big section, and I'm going to do a demo on continuous integration and release. My experience with CI/CD in previous jobs and stuff has been that in a lot of cases they are poorly documented black magic rituals, right? Like it's this process where, you know, the docs are either not there or really incomplete or outdated, and like there's a few special people that know how it works, but the rest of us are clueless, and it's kind of hard to maintain and hard to update because no one wants to touch it, kind of thing. Or usually a release or your CI pipeline and your releases end up being just basically having way too much setup and coordination. So these two things for me, I've seen them personally as being really big pain points in release and deploy processes. And my goal is to always try and figure out how can we make it as simple as possible. So controversial opinion, if your release or your deploy process can't be described in a few short bullet points, you've got problems, right? So I'm going to throw that out there, and that'll probably offend some people, but I think it's the truth. So just an example on the app metrics repo I spoke about. This is the entire description of our release process. The actual step, how to do it, is this long, and the rest is just explaining what happens when you perform that step, right? So it's super simple, and this is something we should always strive for, in my opinion. It should be so easy to do releases. So that's the goal. Let's make it ridiculously easy. So I'm going to give you just a couple of tips, I guess, on how to get there. So use this concept of jobs, right? Usually, instead of having this big, long, massive like script or build file or whatever it is, depends on your environment. Instead of having this one massive thing that defines the release, you should break it up into really small jobs, right? So a job is a small task with one purpose: build, test, push, deploy. The idea is that you could run the build job on its own and it'll work. You could run a test job on its own and it'll work. And they're kind of not entirely dependent on each other. The reason that I think we should do things this way is because if you have these broken into single purpose jobs, they're modular and they're reusable. You know, we can use them across different projects that are similar. We can take them and modify them slightly if you need to. And the smaller a job or a task is, the lower probability of it failing is. And that's just a fact. Like the bigger something is, the more ways it can break. So what we do with those jobs is we take them and we define a sequence of jobs. So like a pipeline, right? And what we can do is execute certain jobs based on conditions. So for example, if I've got a project and I've got my CI/CD pipeline in place, one of the developers on my team might open a pull request, and the sequence there might be to just build and test because it's just a pull request. And what happens is if we decide, oh yeah, we're happy with that, we're going to merge that pull request, the same sequence is going to run again, but this time there's an additional condition. And the condition is that it's been merged, it's on our master branch, whatever. So what we'll do is we'll do a push. We'll push a container image, or we'll do a release or something. So based off the fact that it's on a different branch, or based on tags, based on different conditions, we can optionally execute additional things. And so this gives us a nice sort of modular CI/CD pipeline that's kind of easy to reason about as a person as well. And it's easy to maintain. So one little pro tip, always look for off-the-shelf tooling. So in those build and test and push and deploy jobs, try to avoid writing your own custom tooling as much as possible. Like, always look for something that's already out there first, because it's just probably going to be more robust. Like, we all have a tendency to write these kind of crusty shell scripts that like eventually they hit an edge case of some sort and they fall over, and over time they grow and grow and they become hard to maintain. So if we can, we should avoid this kind of thing. It's not always possible, and sometimes we need some stuff to glue things together, but that should be the goal, is to glue other things together and not have to build those things, right? Just glue them together. So in my opinion, the release process, the release, the build, whatever it is, it should have one entry point. So there's one way of kicking off the build or the release. And the less parameters that go into that release or that build or whatever it is means less room for error, right? So it's not always easy to avoid this kind of thing, depending on your environment and depending on how many different configurations your app might be, that you might be able to deploy your app in. But generally, the less amount of inputs that go into your process, the easier it is and the less chance of something going wrong. So something that I've found to be really, really useful is Git tags, right? So let me go into the Hello World server and show you what I'm talking about. So these are Git tags. These releases correspond to a Git tag, right? And each release corresponds to like a Docker image that's been pushed to a registry somewhere. And what I want to show you is how we can basically create this super kind of robust automated release kind of process that allows a developer to release something really easily without having loads of knowledge beforehand. And then hopefully we'll be able to get it deployed somewhere as well. So let me see, sorry, I was looking at the app metrics, but we use the same process in the app metrics, but I want to do it in the Hello World server. So, so we've got some releases here, right? What I'm going to show you, we use Circle CI. I've also got an example of how you do this with Travis CI if you're interested in Travis too. It's the exact same process has been kind of done in both different services. So what I have here is my jobs, like I just described earlier. We've got a job called build. We've got a job called Docker push master. We've got a job called Docker release. So the build one does build and test. Maybe we should separate those, but it's kind of a small thing, so it's okay to do it together, I guess. But those are our 3 separate jobs. And then down here, we define our sequence, or in Circle CI terminology, it's a workflow. And this basically defines how our jobs are going to run. So we're going to run the build job. And that's going to, this is like weird filtering stuff that Circle CI does for conditionally executing stuff. But basically, this is going to run all the time on pull requests, on master, everywhere. We're always going to test something, right? Build and test. But then, if the commit was on a master branch, we're going to do our Docker push master. And then, so that what that means is, like, if someone opens a PR, it'll get built. And then when the PR gets merged, it gets built again, but then an image gets pushed to Docker Hub, but not like a release image, but just a master image. I'll show you the difference in a few minutes. The next one, then is Docker release. So this is our actual release. This is like if you want to release a new image to your upstream users or whatever. And what happens here is basically only if a git tag is present with a particular format will perform the Docker release. So I'm going to show you what this looks like. Let me see. All right, so I've got Circle CI here. I'm going to start off and create a release. So 0.1.1. Hang on. 0.2.4. So we're going to do 0.2.5, let's just say. We're going to hit publish. So what we've done is we've just created a release in GitHub. But if we go into Circle CI now, we'll see that a new build has started. And we can take a look at this workflow and we can see that the build step is going to run and then the Docker release step is going to run, right? Because it's a git tag. So the build is done. The build goes in and runs the unit tests and it uploads code coverage to coveralls, all that kind of good stuff. And then we perform a Docker release. So this is going to basically build a Docker image, attach the version number that we created as part of the git tag. We're going to tag the Docker image with that tag, and then we're going to push it to Docker Hub. So let me go to Docker Hub real quick while that's still building. Oh, you're kidding me. Oh my God. Oh, hang on a minute. So definitely gonna have to change my password after this, but there you go. All right. Logging in. This is being strangely slow. But we can see using these make commands that we have, they're just essentially small wrappers around the Docker build and the Docker push. That stuff has been pushed to Docker Hub. I just want to log in so I can show you. If it will ever load.
Looks like everybody is following the release steps at the moment.
All right, so we can see last pushed a minute ago, and we can see that our new tag has been created. And also, as part of release, we like to update the latest one. So that means if someone did a Docker pull latest or a Docker pull 0.2.5, they would get the version that we just released. I can actually show this off real quick, right? So remember earlier on, I showed you this hello world thing with the version. We're going to use that to just kind of verify that everything works later on. So what we've just shown off is this really, really nice, very quick release process. And just as a little bonus as well, we use this Golang tool called Go Releaser that builds that we call as part of our CI process. And that Go Releaser tool will build binaries for like Windows, OS X, for Linux, and it'll also generate a changelog for us. And then it automatically attaches it to the release that you created after the fact. So I refresh GitHub, and now I have all of this really pretty stuff that's been put here. So anyone can go and download this particular version for Linux or for Windows or for OS X. They can get the raw source code. They can see a changelog that shows off all the commits since the last release. So it's a really nice thing. So it's a super simple process to follow. It's really easy to understand. If you're interested in this kind of stuff, definitely check out the repo, because it'll definitely help you kind of get started with something similar. And even if it's not Golang, the same kind of idea can be used for any project. So you do your build, you do your test, and then you do your Docker push or whatever. And here's a really nice format that's super simple to follow. This is the Travis file, and this is the Circle file. All right, so that's kind of nice. That shows off how we can basically, at the push of a button with one step, just the push of a button in the GitHub releases section, we can kick off a build, a test, and a release, and that gets released somewhere on Docker Hub. But what if we wanted to take it further and actually deploy something, right? So literally push button deploys, right? This is a concept that the first time I ever heard the word push button deploy, immediately I was like, yes, that is exactly the way everything should be. Everything should be push button deploys, right? So let's actually do that, right? And we'll do it by just modifying our Circle CI thing a little bit to deploy somewhere. And what we're going to do it with is with OpenShift IO. So if you're not familiar with OpenShift, it's essentially a Red Hat kind of distribution of Kubernetes that adds lots of nice features. I won't get into it much more than that, but kind of a lot of the new kind of stuff that we're working on in the AeroGear community is all designed to run on top of OpenShift. So we're kind of heavily into OpenShift at the moment. So there's this online offering you can use called OpenShift IO that they'll give you like a small free instance that you can kind of have your toy projects on if you want. So it's great for like demos and stuff. So you get like this one little 1 gigabyte kind of instance where you can do stuff. So this is the cool part of the demo if it works. So what we're going to do, we're in the OpenShift console now. We're going to create a project. Go hello server. Doesn't matter. We'll create. All right. So we've got our Go Hello server, right? And what we want to do is we want to deploy we're going to deploy the image that we just published a few minutes ago, this one. So we're going to take the name and we're going to deploy an image. So we're going to use an image name. We're going to call it latest. So basically we're saying we want to use the latest version of the Hello World server to deploy that particular tag. So it's after pulling up some details, it's able to like inspect your Docker file and then figure out that the app wants to run on port 4000 and a bunch of other stuff. It complains about how this thing potentially runs as a root user, but it doesn't. So it's okay. OpenShift will make sure that it doesn't run as a root user. And yeah, we shouldn't need anything other than that. So we're going to hit deploy. So we're going to give it a few minutes. Hopefully it shouldn't be too long. So we can see a deployment is already occurring. It's pulling the image. We can go in and look a little bit closer. So the deployment is running. And it looks like our server has started already. So what we're going to do real quick is, where is it? Actions. What we want to do is to expose the application to the internet. And here it is. This is the button, create a root, right? So once it's deployed, it's there inside the OpenShift cluster, but it's not available to the public internet. But we can essentially press a button to allow that to happen. I love being able to do stuff just by pressing buttons. And fingers crossed, we should get our app. Maybe not. Maybe it takes a few minutes for the endpoint to get registered. So we're going to give it a second. $4,000, so it's expecting 4,000, and we'll just make sure if we go into the the actual app itself, we can look in the logs. Okay, we can see it is listening on 4,000, so give it a few seconds and we should get our app. Okay, there it is. All right, awesome. So our app is running. It's the Hello World app. Got version 1. Just for the fun. YouTube. So hello YouTube. There we go. All right. All right, so we've got our app running. But now we want to be able to hook up what we have in OpenShift into the sort of build and release process that we have going on in Circle CI, right? So that we can get this kind of cohesive, full pipeline where we can just press one button and have the whole thing deployed. So we're going to do that now. All right, so we're going to go to my editor. This is the Circle CI file that we have. What we want to do is define a new job called deploy. And we're going to do some stuff in there to deploy in OpenShift. All right. Now, luckily, because it would be just tedious if I wrote all of that stuff out, I have it here in another file. So we're going to get that going quickly. All right. And then what we want to do is have it run. We want to actually add it to the sequence, to the workflow. So basically, the OC deploy job is going to run after, it requires these jobs to have run first, and it's going to run when a tag has occurred. So basically, if we create a tag, we're going to get a build, we're going to get a Docker release, so it gets pushed to Docker Hub, and then we're going to kick off our deploy. So 3 simple steps. And basically, what we're going to do is we're going to tell OpenShift that our image has updated, and that's going to automatically kick off a deployment. Let me kind of explain that a little bit more. So if we go into OpenShift, into this deployment, right? So that kind of wizard that I showed you a few minutes ago where we put in the image name and it created all of this stuff for us automatically. Under the hood, this is all represented by this kind of YAML definition. So there's a bunch of different Kubernetes and OpenShift related resources getting created in here. And one of the things that we have is this trigger, right? So triggers are kind of like events in OpenShift that will trigger a new deployment, right? So the trigger on the deployment, basically when one of these events occurs, a new deployment will kick off. So we can see in here that there's this guy called image change. And basically what this is defining is that we've got this image called go hello server latest, and essentially when that image changes, a new deployment is going to kick off. Now, one thing, just a small caveat is that when we actually told OpenShift, deploy this image for me, it actually imports that image into the registry within OpenShift and then deploys the image from there. So if I just updated the image in Docker Hub right now, OpenShift won't actually register that as a change to the image, right? Because it's actually referencing its own copy of the image in the registry, right? You can go in and see that in here, right? So this is the image that was pulled in from Docker Hub. So if I update this guy here, this guy doesn't automatically get updated, but we can really easily update that with a single command. So, and when that gets updated, the whole automatic trigger deployment stuff will kick off. So let me go back here. So what we're going to do is use the OpenShift command line tool. So to kick off the deployment, right? So these steps are essentially downloading the latest version of the tool. It comes in a tar file from GitHub. We're going to, unpack it, make the whole thing executable, and then we're going to log in using my token. We're going to select the project, and then we're going to call this import image command, and we're going to use the name of the image stream, which is this guy here, right? This is my Go Hello Server image stream. So we're basically telling OpenShift, update this image stream. And what that does is it'll go off and get the latest version from Docker Hub. And when that happens, it notices that there's been a change, and then a deployment should kick off. So I'm just going to go into Circle CI first and make sure that I have all of the appropriate environment variables set up. So we've got an OpenShift token. We also want OpenShift project. So we're going to add that as well. And it's called Go Hello Server.
You have the $sign in there.
Oh, thank you. And then we've got OpenShift image stream. And that's also called Go Hello Server, right? So now what we're going to do is commit this and push it, and then create a new release. All right, so we're going to kill. We'll do it in here. Right, so hit status. Did I save that? Oh, I didn't save it. Now it's saved. Status. All right. I'm going to go through the whole process. So we're going to commit that, and we're going to push it. Origin. All right, so we go back to our project, and we can see this new branch has been created. We're going to create a pull request. Now we can see Circle CI is running a build, and if we go into the details of that, we can see all it did was run a build, right? Because it's just a pull request. It was super quick. All it does is run a build. Now I'm going to say I'm happy with that pull request. I'm going to merge it. So it's been merged to master, right? So if we go back here, we see another build. This time we're going to do a build and a Docker push master, right? Now, this isn't going to kick off a deployment in OpenShift, because what happens when we do a Docker push master is we're updating this master tag, and of course we're not running the OC deploy job, right? So nothing's going to happen yet, right? But we can just let that continue for a minute. So one thing I love about Go as well is it's like the building and the testing and everything, it happens so quickly. Like we've got this automated release process that you can run with a single button, and it takes, you know, a minute or a minute and a half, and it's fantastic. So that's built, and now it's pushing. Just so last push 3 hours ago, last pushed a few seconds ago, so that worked. All right, so, okay, our changes have been merged to master. And I've just realized that I actually wanted to do one extra thing, so I'm, I'm gonna do it real quick. Right, we're gonna change the version number too, right? We're not going to go through the whole pull request and everything again. We're just going to push it straight to master just to get it done quickly. So let's check out master. All right. All right. Push. All right, so that's going to kick off another build and all that kind of stuff, but we're going to just go straight ahead and create a release now, right? So we've created we've got a master image getting built right now, but now we want to actually do a deploy, right? So if we come back in, you can see that those changes are here. So we should be all good to go. I hope it works. So we go to releases. And what we're going to do is draft a new release, 2.6. I know the version number in the thing, in the actual script that I showed you a second ago, is not the same, but it's just quick and dirty demo stuff. It makes no difference, really. All right, so if we go back to Circle CI, we can see this 02.6, this is the tag one. We can now see we're going to do a build, we're then going to do a release, and then we're going to kick off an OC deploy, and hopefully this guy doesn't fail for a really small reason. So you can go in, you can drill in and look at what's going on, just to make sure our service is still there. It is. Version 1. Just keep it back here. So we're just waiting a couple of seconds. It shouldn't take too long. So what's happening is we're pushing to the Docker registry. And once we've pushed to the Docker registry, we're then going to download the OpenShift CLI tool, log into the OpenShift instance, and basically tell it, hey, download this new image, basically re-download the latest image again, because there's a new one, right? Re-download that image, and cool, it worked. So hopefully we should start to see a new deployment kicking off. Awesome, new deployment, rolling deployment, right? Deployment number 2 is kicking off. And we can see, if we go into the deployment as well, really nice feature of OpenShift and Kubernetes in general. It keeps the current version of the application running while it brings up the next version, and then it switches over once the next version is running correctly. So let me see. All right, so it looks like our application should have been updated. We may see the unavailable sign, but I hope we don't. And we've got version 2. Awesome. So what we've just done is built and released and deployed our application just by creating a release in GitHub. Like it might seem like a simple thing, but this is really, really powerful. Like, this is the ability to deploy your software without the need for even a command line. Like, you could do this from your mobile phone, from anywhere. And I just think, I don't know, I think it's pretty awesome. It's a really nice process to have. It's so robust. It's got a low number of parameters. It's got one entry point. It works quite well. The part where we deployed it to OpenShift, that could easily be, you know, whatever system that you use, whether it's something completely different. It doesn't matter, right? But the idea is the same, and I think it's pretty nice. So I hope it kind of inspires other people to look at the way that they currently deploy software and try to figure out how they can make it simpler. Because I think it should always just be super simple, right? And that's it, really. That's all I have to show. So thank you for watching.
Perfect. Thank you, Dara. It was really interesting and impressive demo. Specifically, the latest part was the live push of the image updates to OpenShift. That was really powerful. I'm sure folks that are getting into Golang will definitely appreciate the introduction. Specifically, it's around tools that are supporting you best and automation. So this is definitely very valuable information. Thank you very much.
Thank you.
Yeah, I think that's it for this episode of the community broadcast or live hangout. I really hope that we will have a similar format in a few weeks again, because this is kind of interesting, where we can basically present our latest, greatest developments in the live hangout as an opportunity to to just present the stuff that we have there. Yeah, I really hope folks did enjoy it. I was really enjoying the talk, Dara. Thanks again for joining us here and giving us this nice ride. Thank you very much.
Thank you too.
And then see you on IRC. Bye-bye, man. Take it easy. Happy Easter.